Hello and welcome to Pictorial Planet. My name's John Finch. Today I want to give you some tips on making developers with organic solvents. Now when I talk about that, I mean developers like 5,10-pyro, Pyrocat HD in glycol, or the one we're going to look at today, which is Gainer's PCT. Now the reason I want to show you this is because people have said they get thin negatives sometimes from these organic solvent developers, and I want to demonstrate what might be going wrong. It's quite simple, but it's very important. Let's get to it. So organic solvents that are used in developers that we make at home are propylene glycol, also called monopropylene glycol, or TEA, which is triethanolamine. They're slightly different in character. We'll talk about them as we go along. But what I'm going to do first of all is dissolve my phenidone into some propylene glycol. Now, phenidone can oxidize whilst it's in the bottle and doesn't last forever. In fact, if your phenidone is getting older than 6 months, it's starting to deteriorate and you're going to find it more difficult to dissolve into water, and its developing activity is going to slowly start to deteriorate. I've had this for about 6 months and I've used some of it already, but I'm deciding that I want to really keep this as long as I can, and the way to keep phenidone is to dissolve it into propylene glycol. Now you can't just dissolve it willy-nilly. You need to dissolve it as a percentage amount so that you can then dish it up again into other developers that you're making. So I'm going to make a 1% solution of this phenidone into this propylene glycol here. So I've already measured out 100 milliliters of propylene glycol. The second part of today's video is going to be making PCT. I've got a bottle ready here. PCT is one of the famous Gainer developers. He didn't like sodium sulfite and he liked to make developers as simple as possible. So he made this particular developer out of phenidone, vitamin C and TEA here. So we're going to actually utilize what we make here with the phenidone in that developer. Now, I want to stress that it's quite important that you do it this way, because this is going to help your developer maintain its activity. So watch carefully, there's a lot of tips here for you guys. And this covers 5,10-pyro as well, which uses some of these chemicals, ascorbic acid and vitamin C as well. So first of all, I need to make my 1% solution of my phenidone. So I've measured out my 100 milliliters of propylene glycol already. I've got my scales ready here, and I'm going to measure 1 gram of the phenidone. So 1 gram into 100 is 1%. Easy to remember that. So I'll just get my phenidone and I'll just gently measure it out. I'm going to do it very carefully, very slowly, because I want this to be very accurate. There, 1 gram exactly. This is when a set of chemical scales is very useful. You can't get this kind of accuracy with teaspoons. So here we are, 1 gram, and I'm going to put this phenidone into the propylene glycol. I'll get my stirrer and I'll stir it in and break it up. Now you'll see straight away that it doesn't really, let me hold this closer to the camera for you, it doesn't really dissolve very easily into the propylene glycol. So the best thing to do is warm this propylene glycol up. But here lies in the problem. If you warm phenidone too much, it will deteriorate and break down, and then your developer will become weak. And you'll wonder why your developer isn't as active as someone else's. So what we have to do is to warm this up very carefully, a little at a time, until this is dissolved. Very important indeed. Let me just get myself another jug here, I'm going to just pop this stirring stick into this jug, and I'm going to pop this in the microwave, and I'm going to give it 10 seconds. Now 10 seconds is not going to make this particularly hot. It's just going to start warming it up. Let's have a look. Alright, 10 seconds, and I'll bring it out, and it's hardly warm to the feel. I'll give it some more stirring, and you can see it's actually starting to dissolve, which is exactly what we want. We need to dissolve this at as low a temperature as possible so that we maintain its activity level. Yes, that's going nicely. I think one more little heat might be enough. So let's just try that. Microwave, 10 seconds, start. Now I have a kind of general rule that I use when I'm mixing phenidone into propylene glycol, and that is it should never be so hot that you can't hold it in your hand easily. If it gets hotter than hand holding temperature, you're starting to break the phenidone down. So basically you can see that's going right into solution now. It's nearly there. Give it a little bit more stirring. And that's just about in. 2 little bursts in the microwave is all it took. And it's not hot, it's warm. Now, propylene glycol protects the phenidone from oxidizing, so it keeps the phenidone really well for a long, long time. There we are. There's a few little crystals left, just a few, and they will dissolve in their own time. And I've maintained that phenidone at its highest activity level that I can. So I have a bottle already, 1% solution. It's marked up as a 1% solution, and I've even put on 10 milliliters of this solution will impart 0.1 grams of phenidone into a developer. So I'll carefully pour this in. Now there's no better way of keeping your phenidone, so you want to do this whenever you get phenidone in and it's fresh. There we go. I'll pop that there. I'm pleased with that. Now the next part of our video is going to be making the PCT itself. So PCT is a very simple developer to make. One of the classics, doesn't use any sulfite, and uses its own alkalinity in order to activate itself. So the PCT is almost like a rodinol that works all by itself, or a 5,10 pyro, but without the pyro, without that more toxic factor. This is a much simpler developer to make. And it uses TEA, or triethanolamine, as its organic solvent. And the reason it uses that is because when this organic solvent is dissolved in water, it becomes alkaline. And when it becomes alkaline, it then activates the developing agents within it. And the 2 developing agents that it has are the phenidone and ascorbic acid. And be warned, you cannot put sodium ascorbate instead of the ascorbic acid. It's important you use ascorbic acid in this formula. Now the formula asks for 9 grams of ascorbic acid and 1/4 gram, 0.25 grams of phenidone. A very small amount to measure, but now that we've made our 1% solution, you'll see how easy this is going to be to measure the 1/4 gram. So the first thing I need to do then is to dissolve in the ascorbic acid into the TEA. So I've measured 75 milliliters of TEA into this Pyrex jug. and I'm going to measure 9 grams of the ascorbic acid. Now this is nice and fresh, this ascorbic acid, so it should be fully active. One of the great things about this developer is it keeps for years. I mean, it is as good as 5,10-pyro in its keeping qualities. There we go. So there's 9 grams of ascorbic acid. We're just going to put it into the TEA, like so. These chemicals are relatively harmless. The phenidone has very low toxicity, and of course the ascorbic acid is vitamin C. So that's low toxicity levels as well. So this is a pretty safe developer to have around if safety is important to you, if you don't want to have toxicity or toxic chemicals around. Maybe you've got children or you just want to keep them out of your life. This is a good developer to use. Now here we are, I'm trying to show you this. There's the ascorbic acid going in the TEA, and it doesn't dissolve easily. So again, we're going to have to warm this up. And again, we're going to have to try to keep it as low a temperature as we can to maintain the activity of the ascorbic acid, because if you make it hot enough, it will break down and become useless as a developing agent. So I'm going to put my stirring stick here in this jar, and I'm going to warm it up, and I'm going to give it 20 seconds. And I know that from experience of just doing the phenidone, that it took 2 10-second bursts to get it up to a warm temperature. Here we are. And it's definitely warming up, but it's not hot by any stretch of the imagination. And I can already see, and I hope you can too, that it is beginning to go into solution. It's just what we want. I've always found that the fresher my chemicals are, the easier they are to dissolve. Notice that I can still hold it in my hand. It's still holdable. It's not so hot that I can't hold it. So we keep stirring this. And it's definitely going in. Most of it's in, but there's still a fair amount on the bottom. But if most of it's going in, that means that if I keep stirring, it will all go in. It must be warm enough to dissolve the ascorbic acid. It's nearly there. The liquid is getting clearer and clearer as I continue. I'm just going to put it down here just to make it a little bit easier for me. There we go. Just crush any of the bigger crystals or clumps. I'm going to give it one more. It's still not going all in yet. I'm going to give it one more 10 seconds. Partly because it's cooling down as I'm stirring it, and partly because I want to push it just a little bit hotter. You can see that's clearing nicely. Very nice. Now it's quite hot now. It's only just holdable in my hand. So that's as hot as I want to get it. So now it's a case of stirring until that goes into solution. Now some of you are going to ask, can I dissolve other chemicals into TEA or propylene glycol? Well, not all chemicals will dissolve into these two organic solvents. And generally speaking, in my experience, it has to be organic chemicals. So ascorbic acid is an organic acid, whereas sodium ascorbate, the chemical used in FX55, for instance, is not organic. It's a salt, and it won't dissolve in either of these two. So only certain chemicals. If in doubt, give it a try on a little test. Pour a little tiny bit of your organic solvent into a jug and add a tiny bit of chemical and see if it'll dissolve. But by and large, only organic chemicals will dissolve into an organic solvent. Like dissolves like. There. Look at that. It's all dissolved. It's all gone in. Now, if I add my phenidone now, what's going to happen? It's going to be heated up to the same temperature as that TEA, and some of it will be degraded. So the next thing to do then is to let this cool down before I add the phenidone into it. So I've let it cool down and it's easily held in my hand now. So it's nice and cool, definitely cool enough now for me to add my 1% phenidone mixture. Now the formula calls for 0.25 grams, 1/4 gram of phenidone, and I have a 1% solution. So 10 milliliters of the 1% solution will make 0.1. 20 milliliters will make 0.2. So 25 will make 0.25. So I need 25 milliliters of my solution here. I have a measurer that measures 25 nicely for me, so let's pour this in here. There, 25 milliliters. Put that in. Give it a stir. And she's come up to 100 milliliters perfectly, just right. Give it a good stir. Pop the top on this for safety. And I know that I've made this PCT as cool as possible. The way I put it together is as coolly as possible, so I have not spoiled any of the developing agents with too much heat. I have a bottle already set here, so let's pour it in there. Nice, lovely. And put the top on. Now, PCTs used 1+50. For development times, I use FP4 at between 7 and 8 minutes, and HP5 9 to 10 minutes is what I'm normally developing that at, and that's 1+50 is the dilution. So I hope that's been useful to you guys. It wasn't about PCT so much as about how to make an organic solvent developer to be as active as possible, and why you might see some development times on the net that are way out from what yours are, or you might find that your negatives are too thin and you're wondering, why are my negatives so thin? Nobody else is talking about this, and that's probably why it's happening. So give us a thumbs up. Thanks for watching the channel, and subscribe to the channel. There's lots more where this came from. I want to have a big call out for my patrons. Thank you ever so much, patrons. You are keeping this channel going. You are the ones that help me get all the things I need to demonstrate these kind of things, and also be able to take time out to write my book. So I will see you all next time.